Welcome everyone to another observability clinic. It's part of the tips and tricks session for our community. It's episode 6 already, getting started with OpenTelemetry and the OneAgent SDK. I have invited Sebastian. Sebastian, welcome to this tips and tricks session.
Hello, everyone. Today I would like to cover a few things. Obviously, OpenTelemetry and OneAgent SDK things because these are my main point of interest right now. But I want a little bit make closer to you how the instrumentation process should look like and how you can prepare to this process. Because obviously, even if you really know well the technologies you are working on, you already know the OpenTelemetry and OneAgent SDK, you need to as well be prepared to what you want to do. And first of all, you need to properly design the instrumentation process of your application to not over-instrument it, to not make too much work, to make it efficient and as simple as possible. And from the technical point of view, if you know what you want to do, it doesn't matter if you use OpenTelemetry or OneAgent SDK for C or other SDKs for other technologies if are available, because all those instrumentation, the whole instrumentation process will look exact the same. You need to be on the same points in your code. You need to think about the same data you want to collect. And these are only tools, but those tools have some different approaches related to how they work, what they need to work, and how you can start to play with them. And this is something I want to cover today as well.
And Sebastian, first of all, thank you so much, because you've been doing this quite a bit in your work at Spica Solutions. And this is why it's really great. This comes from somebody like you that has instrumented a lot of apps, especially on technologies, as you mentioned, that might not be already covered with perfect auto instrumentation, either through the OneAgent or through OpenTelemetry, but really certain things just need to have some manual instrumentation, certain technologies where auto instrumentation doesn't work, like C, C++, right? And that's why it's great that you cover these technologies and best practices.
Yes, this is one thing. Another thing is that based on this knowledge, you can build your own agent for technologies that are not supported by Dynatrace and OneAgent. And this is something I will show you later on as well on live demo, because we have such product. And let's move back to the main topic. So if you are thinking about instrumentation of the process, most customers I was talking about was thinking that they need to mark every point of the code to make everything work as they expected. And this is because they are not thinking about the monitoring and the telemetry in general. They are thinking about resolving some points they are struggle with and they don't know where to look for. And because of that, they are trying to instrument everything. And this is not a good approach because obviously even a regular OneAgent doesn't work like that. If you will install OneAgent and start monitoring Java application, you will see the entry points, the exit points from the app, so outgoing requests, queries, database statements. You will see exceptions, and in really short words, this is what you will see. Obviously, those entry points have different types, outgoing requests are different types, etc. So you have plenty of data, but in general, the key is to understand where you are losing your time or where you have errors between points that can be instrumented really quickly. And this is starting point. So first of all, you need to think about monitoring and as a process. You need to design it because each app is different. When you prepare your code for the instrumentation, it should be much, much easier to start, because if you have C++ application that has everything in separate classes, separate files, and you don't have any general point you can touch to make to add visibility to your monitoring, you will need to go through all those files. When you think about instrumenting your application with OpenTelemetry, for example, and you are at the point where you are designing the code, you can think about some middleware classes or some super classes that can be then instrumented, and they will provide you from single point in the code information about the bunch of other classes, other entry points, and you will not need to maintain this part. So this is something that you need to concern about. And if you are using frameworks, because for C++, even there are frameworks for building apps and some customers are using them. Those frameworks has implemented such points because they have, for example, middlewares that you can put to process the request in the beginning of the existence of this request inside the application. And this is the good point, for example, to cover incoming web requests. Sometimes customers are building own libraries for the communication protocols. You can put OpenTelemetry there as well and see everything that is going out of your application from this library without touching the code, the business code that is really important for the organization. It's easier to maintain. You can add something new to your application and still the monitoring will work. If you will do it smartly, you will not need to rebuild everything each time when you modify the application. But what are the challenges for the manual instrumentation? Obviously, even if we are doing this smart, we will have some extra code that we will need to maintain. If we will use some standards like OpenTelemetry, we can be pretty sure that this standard will keep the legacy and support for the code you've implemented for some period of time, and you will there will be no need to change what you've prepared. If you will do own approach, because some customers are trying to, it is not so, you cannot be so confident about that you will not need some changes in the future. And this is really important to think about such things when you put something to your code, especially if there is permanent injection to the code. Instrumentation needs to be developed with the app. So if you are sure that you've instrumented the points that will cover new functionalities in the future, and you will see them in the traces, you are safe. But if you have to put something in some special places picked for particular reason, you will need to think about modifying this and maintaining this part of the code with the application as well. And this is why it's so important to not over-instrument the app, because if you will make too many points, you will have too much effort on your application to make everything work as you expected. As I said, frameworks or other components that are used to instrument your application from time to time has some updates. So if you are using standards like OpenTelemetry or OneAgent SDK, those technologies are focused on not changing everything from one version to another. So even if you will update some third-party components of these technologies, you should be safe in terms of monitoring. Why it's so important to not over-instrument the app? One more important point, because if you will pick wrong points, for example, methods in the code that are executed too often, you will have too much traces. You will have too much data. This is one point. Another is that you can produce overhead on your application because you are processing too much data. And this is something you need to think about as well. OneAgent is making us lazy because it's doing such things for us and we don't need to think about it. But if we want to start doing such instrumentations by ourselves, we have to think about this part as well. The really important point is to plan what you want to do, because if you will not plan the instrumentation process, you will always think about, okay, I will put one more tag here, one more tag there, one more point here, and everything will be not as clean and not as good as should be. And of course, collecting all those data needs to be transparent for the application. So we do not need, we shouldn't produce any overhead on the app. And this is really important in terms of amount of data we are collecting, the way we are collecting those data, about the points we picked to collect data, because some of them are really sensitive and we cannot just instrument them. There are some transactions that are really, really fast. So they are taking less than 1 millisecond because they're atomic transactions. If we instrument them too widely, we can produce overhead, for example, 200 or 300%, which still makes them fast, but it may be really problematic for the application. This is something we need to think about as well. How in general manual instrumentation works, and it doesn't matter if we are talking about OpenTelemetry or OneAgent SDK. Obviously, this is only example. So if we are thinking about, we need to pick one of two ways to make it clean for our application. I prefer option 2, but the option 1 is fine as well. Option 1 is putting the tags that are collecting traces that are measuring our application performance directly inside the methods in the code. This will obviously work, but it is adding extra layer to this method. So if you are then trying to analyze the code, you need to dig through all those extra lines that are responsible for collecting traces, collecting exceptions, measuring stuff, sending some metrics and other things. And the business logic is between of that. And it can be sometimes hard to read. And this is why I've picked the option 2. So we are changing the name of the original method, for example, to the old or not instrumented, without instrumentation and other things. Its semantic is it depends on us, and we are creating the same method that is invoking, overriding our old one, and inside this method we are putting only the instrumentation. So we have one method that is responsible only for measuring everything, and then we are executing exactly the one we want measure, and there is the business logic, and we have clean code. So this is something we need to think about as well. Okay, so let's move to the OpenTelemetry stuff. And I will focus today mostly on the C++ implementation, because I think it's less documented related to other ones, because technologies like .NET, Java, PHP has auto-instrumentators from the OpenTelemetry side, so it's pretty easy to start play with them. But if you think about OpenTelemetry for applications that are not be able to instrument it in other ways, which is a really good example of implementation of this technology, you need to consider as well C++ applications. And from our experience from the field, from our customers, each customer has some systems that are written in C++, and it's not really easy to convince them to instrument those systems with Dynatrace OneAgent SDK for C, because obviously they are selling, okay, right now we have Dynatrace, we're happy with it, but I don't know what will be in 2 years from now. And then all this stuff has to be removed or disabled somehow, and what to do with that? We can then ask them, so let's use OpenTelemetry thing. Dynatrace obviously can collect those informations, can collect those traces, and you will still have argument for them that they can use the same instrumentation for different purposes. So this is why this I think it's so great. So first of all, why OpenTelemetry? First of all, it's the standard on the market right now. It's still in developing, and from 1 month to another, I see new stuff or different technologies that are covered by OpenTelemetry. The community as well is producing own extensions to them that are, for example, instrumenting extra parts of the code that are not covered by the technology in general. But it is standard right now, and you can be confident about the effort you are put into the instrumentation that will be not wasted. Many observability solutions supports OpenTelemetry right now. So you have this argument for the customer that even if they will have different ideas in few years, I don't know, I hope not, obviously, because Dynatrace is the best solution on the market, and I am confident about it. But if they will have some decisions, for example, from the group point of view, because sometimes we are working with the customers that is, for example, division in Poland, and they have group for the whole Europe, and sometimes there is decision from the group to switch to another tool, and then this instrumentation still will work. You can get advantages of those traces even if you are not working on x86 computer, because many developers that are using our solutions has problems because we've prepared solutions based on OneAgent SDK for C. They are working on Linux, Mac, but Linux and Windows, they are not working on Mac, for example. And in such case, if they want to use tracing, they need to build the app on their system and then put it to some server which is instrumented with OneAgent and our solution, and then they see the transactions. But sometimes they want to dig, for example, on their own laptop, and OpenTelemetry can allow them this thing. So this is something really important. I've said that we have auto-instrumentation for some languages like Java, JavaScript, .NET, PHP, and more of them. Obviously, OneAgent is supporting those technologies as well. So if we can use OneAgent, it's preferred way. But sometimes we have, for example, situation that we cannot install agent, and using OpenTelemetry can be really great because you will see the traces in similar way with the similar layer, similar quality of data, but you will not be, you will not need to install the agent itself. You can use as well OpenTelemetry to create own auto-instrumentation framework, because obviously if there are existing ones, why you cannot use this knowledge to create own one for the technology that is not supported already. So you can create it on your own and give it to the community, or make it the product in your company. So these are the points that are really important. And what is really interesting related to the OpenTelemetry when you are using this technology without OneAgent is that in such case you are only paying for the DDUs that are consumed by the traces. So you are only paying for the traffic you've generated. So this is really important, for example, for some scenarios where we have plenty of items we want to monitor, but we don't want to cover with OneAgent licenses all of this. They, for example, are doing not really huge network traffic. And in such case, we can instrument it with OpenTelemetry, still see the traces, still have the good diagnostics in Dynatrace, but we are not installing agents there. Can we use OpenTelemetry together with OneAgent? Obviously, yes. Even now, you have some libraries, for example, for Java that are pre-instrumented with OpenTelemetry. Dynatrace by itself is not touching this part of the code. Obviously, you can do some instrumentation, but in many scenarios, those libraries has Java wrapper, and below that, you have C code, C++ code that you cannot instrument with Dynatrace out of the box. So you can enable OpenTelemetry tracing for this part, and then you will see the traces connected together. Obviously, you will need to be sure that OpenTelemetry and OneAgent instrumentation will not touch the same part of the process, and this is something you need to have on your mind, that you can over-instrument your application if you will enable too many things at once. But in most scenarios, this is not a problem. And as long as you will provide the proper headers, trace ID and span ID, you will see headers, you will see the transactions connected together, because Dynatrace is using own headers, Dynatrace header for merging transaction, and W3C as well. And these are as well these headers are used as well for OpenTelemetry. So OpenTelemetry can be inside of your whole application chain, and you will see the end-to-end distributed traces for your system, even if you cannot install agent there. So this is something really cool, I think. And what are potential areas we can consider when we are thinking about instrumentation with OpenTelemetry? So obviously native applications, as I said previously, effort put into instrumentation, a native app with technology that is connected only to single vendor can be problematic for the customers. Even if this is really great, it sometimes produces some blocking points in the organizations, and we can mitigate it with the OpenTelemetry. Internet of Things is a great example. For example, ATMs. The banks, most cases, has plenty of them. Those machines are not really efficient. Obviously, you can install agent there, but this agent can produce some overhead because of lack of resources, because they are really old machines. But what if you will instrument the code with the OpenTelemetry and you will send the data to the Dynatrace only then when the customer will do something on the system? You can do that. And you will see the traces, database calls on the internal database, request communications, and other stuff that these machines are using. So this is something that is really promising. I was talking with you, Andy, on the conference about systems on the automotive industry. This is the same example. You can put OpenTelemetry in the car systems and see exactly what's happening there. We have many situations that new cars has broken software, and fixing this is not really fast, because it's really hard to troubleshoot for the vendor and find all edge cases that need to be covered to fix things, and this can be really helpful. We have obviously cloud solutions, and those solutions sometimes are not allowing to install OneAgent. Because these are only as a service, you are not access to the file system, and for some of them, you are not able even to do the pass instrumentation, because it's not possible right now, or it's not planned. But those solutions still can be instrumented with OpenTelemetry. And if cloud vendors, for example, will provide such instrumentation, I know some of them are doing such things, or this is your code, put it into some SaaS solutions that cannot be monitored by OneAgent, but as well, it's instrumented with the OpenTelemetry. You will have full traces that are going through this as well. Without that, in most cases, we see in Dynatrace that we have some proxy that we are going through, and we have some delta of the time between the components, and we need to find out by ourselves that this time was stolen by this part, or something like that. And this can gives us this visibility and this confidence about data, and makes Davis and AI more powerful than ever. Obviously, I was talking as well on developer environments. On our customers, there is problems with the licenses, even for the environments that can be monitored with OneAgent. it's not often and not common to buy licenses for developers. For testing environments, few layers of testing environments, yes, but for devs, not so often. And this can be addressed with the OpenTelemetry as well, because on the developer side, even if they don't have access to Dynatrace, let's imagine that they don't have, they can use still Jaeger or other things that can consume traces from OpenTelemetry and give advantages of this. If we will allow developers to use at least DDUs, they can use Dynatrace as the consumer of this traces and still have even better and even more powerful visibility into what they are developing on their machines. Then they are going to the test environments and the app is working better because we have more bad code and more N+1 errors and other things that normally can happen on our environments. Okay, so let's move to the demo. Andy, do you have any questions about it?
No, I think this was a lot of great information, especially around guiding people that are doing manual instrumentation, not to fall into the trap of doing over instrumentation, really have a plan when you instrument what you want to instrument. I think that was really extremely well done from your side. Now I'm just excited to see it live because you gave a lot of great theoretical background, and now let's see how this works.
First of all, when you want to start, for example, with the OpenTelemetry and C++, there is the documentation on the Dynatrace portal related to this topic. And I want to discuss a few things because it's not really easy to start with that because since the documentation was created, there are some changes inside in the library's versions that are not compatible with the OpenTelemetry. And if you want to build OpenTelemetry CPP for yourself, I suggest using Ubuntu 20.04. You can go through all those informations one by one. Things like CMake, Google Test, and Benchmark can be installed from repositories, and you don't have to build them. But the problematic is the protobuf. And if we go to the documentation of the protobuf, you will see the instruction how to build it using the Bazel with the new version. But the problem is that this version is not compatible with OpenTelemetry. So as you can see here, we have 21.12 version. You need to go back to the older releases. And few releases back, you have version 3.20.3. And this is the one you should to use. And it can be just built with CMake without Bazel. You just download the binary from this, extract it, and then you can install it with CMake on your system. And this will work. And then you will be able to build the OpenTelemetry C++. So this is one thing. Another thing is that if we are thinking about using Dynatrace, we need to configure proper exporters, and this is as well covers here in the documentation. So you just have two options. You can use OneAgent as exporter, and in such case, you just pick this one, pick this header file, and then as you can see here, we are sending traces to localhost to the OneAgent endpoint. This is the same endpoint, the same channel you can use, for example, for sending metrics to through the OneAgent if you are creating some solutions on the host. So you can use OneAgent API and send metrics or OTPL traces there. And other thing is that if you are not using the OneAgent, you can use another header, and then you need to configure the URL to your API, authenticate with the token, and then it should work.
So Sebastian, just for me also to understand, that means if you have the OneAgent installed on that same machine, the OneAgent is opening up a local host endpoint where you can send traces locally. That's why the OneAgent version means if you have OneAgent on that machine, but you're instrumenting that process with your own OpenTelemetry, you can just send it to localhost. Otherwise, you send it to your Dynatrace endpoint, to your ActiveGate.
Yes, and there are some differences in this process, because if you are using OneAgent, I think, as I remember, there is no problems with amount of data you want to ingest. This is one thing. And another is that if you have OneAgent in full stack, you are not paying for the DDUs. So you already licensed this host, and those OLTP traces are treated the same way that PurePaths collected by the regular agent. So you are not billed for that.
Perfect.
If you are not using OneAgent, you are using API through the ActiveGate or direct access to the cluster, you are consuming DDUs for the traces, and there are some limitations in the API to not kill the Nginx that is collecting those informations through the API. So there are two options, and this is really simple app. I don't think it's not. It will not compile because this is only example. I want to show you. So if you go through all this build process, which took about 2 hours, I think, to complete, you can simply add the header you've provided this tracer common to your class, and then just using the namespace OpenTelemetry trace, and then from this point you can start collecting spans. So in PurePath you have different approach. So you have PurePath is something general. So you have parts of this trace, and they don't have I think special name for that. But for the OpenTelemetry, you have trace and you have spans inside the trace, and those spans are single items, single elements that will build the trace for you. And they can obviously be nested. They can be different types of them, and you need to think about what you want to instrument and what kind of data you want to present, because if you will pick wrong, for example, from wrong kind of span, not server one, but for example, as here we have client one for the database statement, you will see different type of data, different type of span will be presented inside Dynatrace, and this can be confusing. What you need to think about when you are creating such instrumentation is providing context. For the auto instrumentators, the context is passed between part of the instrumentated code automatically for you. The same is doing for OneAgent SDK for C. But here, if you, for example, have entry point and then database statements, you need to use the implementation of the context that is available in the OpenTelemetry to provide the span ID and trace ID through whole transaction, to not force you to, for example, give some create some model with those values and go with this model through the whole code inside your application. This will be not efficient, but this solution is providing you such option to make it like that. And I want to cover a few things related to spans. You have single method that is creating span in general, and you need to tell this method what you want to what you are collecting. So first of all, you have the tracer name, the tracer type here you are putting here, and then you can start the span with the actual value you want to present inside of your inside of your trace. So for example, this can be URL, this can be class, method, or other things you want to cover, or for example, database statements. And then you have some attributes. And this is important because different type of data has different attributes. Sorry, need to go back to my browser. And this is something that is documented here. So trace semantic conventions, and you need to understand what you are trying to instrument, because for different type of data, you have different attributes you can put there. And those attributes will be available as metadata on your trace. And they're really important because they are giving you the context about what's happening on your environment. It's not really good information for you, for example, to have information that you have slow database statements if you don't know on what database this statement is working. So for OpenTelemetry, you need to think about those things and cover those attributes, because not all of them are required. As you can see here, required is only DB system. So this is only information about what kind of database engine we have, but others are recommended or required based on some conditions. And to make it work, you need to think about it and provide proper information. And for different type of spans, you have different type of attributes you can put there to expose some things on the spans. This is something I think I will cover in different time. Because there is not really great amount of documentation how to instrument the C++ code with OpenTelemetry. There are really basic examples, and I really want to make it easier for others to start play with. So I think this is something that we'll do in the future.
Yeah, we also talked about Henrik Rexed is doing his Is It Observable tutorials, where he also covered OpenTelemetry. I will add some links. Also, I add all the links that you have open here later on to the recording. So if you're watching this and you want to follow up on the links that you've shown here, we'll make sure to put everything in the thing. But yeah, it's great stuff what you're doing here, and that you're showing us how this works, especially with technologies that don't work just as easy out of the box. And I think that's a great thing to your contribution here.
Yes, because as I said, there are things that are not really well documented but are needed. Sorry, I've moved to the beginning of the presentations. And because of that, there is lack of the documentations. Many projects are not maintained properly. They are not because there is no competence on the market that can cover such things for you. And I want to change it because there are many things we can do with the technologies that are legacy ones, but still maintain, still develop to make them visible.
Yep.
And right now, I will show you few things related to OneAgent SDK. And obviously, I want to go back to OpenTelemetry stuff, some on different meeting because there are many things, and I can talk with few hours about it. And I don't want to make everyone bored. But I think we'll create some stuff from zero to hero, how to start and how to instrument simple app step by step on different approach. But I want to show you something that is maybe interesting related to OneAgent SDK in a moment, because my company since sometimes is quite famous from touching some technologies that are not touched by anyone in most cases. And I will show you what we've prepared related to based on OneAgent SDK. And I will tell you that we are working as well on the OpenTelemetry approaches for those technologies because this is the future and we want to be ready for this. But first of all, let's talk a few moments about OneAgent SDK. Why is it easier to use from my point of view? Obviously, this is because of the integration with OneAgent. You don't need to think about exporter, install the exporter, configure it. Everything is covered by Dynatrace and OneAgent SDK for C, because this is the technology provided for the single solution by single vendor. And this is specialized technology. So as well, you don't need to think about if you are covering all the parameters or the attributes you need to put to make traces of work fine, connect together fine, and other things. Because everything for the OneAgent SDK for C, there is different approach. You are not having single method with plenty of parameters. You have methods that are created directly for particular tasks. So you have different methods and different approach for the web request incoming, outgoing, and other things. And each of them has some parameters that are required. And I think it's easier to start. You need to put less effort to start working with it because it's pre-compiled. You just need to add it to the LD config to give access your application to OneAgent SDK, and then you can do the magic. So the semantic, from my perspective, is simpler. You have full support from Dynatrace for OneAgent SDK for C, obviously. For OpenTelemetry, there is no support. So if you are instrumenting application, it's harder to find someone who will tell you where is the problem. So you will need to figure it out by yourself, or take a look on the community. Maybe somebody had problems like that. But this is something you need to think about as well, that OpenTelemetry in general is open. So it's not enterprise solutions, which is really great and has some disadvantages as well. And of course, based on OneAgent SDK, you can create own agents, and this is what we are doing as we need. And I will talk to you about how you can create agents in a moment. So how you can create such agent, and in general, this can be used as well for the OpenTelemetry approach, because this is the only different layer and different semantic of the code, but the state of mind and way you are doing this is quite the same. So obviously, for OneAgent SDK for C, you need to have OneAgent SDK downloaded and put it inside your project. So if you are, for example, not building app in the C, but this is the app in the other technology like Delphi, Ruby, Rust, or other things, and you cannot just put the C library there and start using it. You need to be able to execute this code inside your application. So you need to think about what are possibilities you can use to make it work. So for our approach, for example, we have own middlewares written in C that are exposing some interfaces from the C code to the code of our choice. And then we have wrapper written in the Ruby, Delphi, and other technologies that can then be used, implemented into your code, and used as simple as possible. So you need to create this wrapper as a communication layer, because obviously putting tags that are translated directly from the C code in other technology is not really easy to read, really easy to understand, and there are some issues that can be addressed related, for example, to translation from the string in one technology to the char implementation in, for example, C. And you need to cover things like that as well. And this is something as well documented in the OneAgent SDK for C, because there is method that is translating strings to the type that is understandable for C. So next part is going through all those things from the first part of the presentation. So we need to plan the whole process, how we instrument that, which parts. Do I need, for example, to create some middleware that will be then a single point of the instrumentation for me, because it may be easier than instrumenting each class or each method one by one, and we need to think about it. Then you can think if this is possible, there is possibility to create this instrumentation on the fly, because some of the technologies gives ability to modify the code on the fly, on the bytecode level, or on the in the memory, for example. So you can modify the existing code that is loaded to memory and instrumented there, or even on the disk, if this is only possible solution. But you can create then agent that will be started automatically and working automatically. You don't need to touch the code of the application. If not, you need to instrument it manually. Next steps are obviously implementation testing, load testing, checking edge cases, because you need to be confident about what you've prepared that is not messing around with the application, and you will have everything you need on the level quality level of data, and you are not producing any overhead, any problems, and then you have your agents working. So our examples, first of all, we have the full working agent that is available in the Dynatrace Hub. This is the Ruby on Rails agent made based on of OneAgent SDK for C. So As I said, we have OneAgent SDK for C, then we have middleware in C, and plenty of Ruby code that is creating this stuff and auto instrumentation process. You just need to install the binary into the application, because obviously you cannot do this automatically from the OneAgent, because we cannot modify OneAgent itself. So this is the only part the customer needs to do, and then magic will happen, and you will see the traces inside of Dynatrace. And we have as well OneAgent SDK for Delphi created, and I want to tell a few things about it, how it's done and how it's working, because these are really interesting examples what you can do if you have need and have idea what that with the tools that are already on the market. And let's see. So first of all, I have here some Ruby demo applications. So this is web application. I can click through them. It's already instrumented with the Ruby agent. I have as well here, I have as well console. So we have some output from this application working. Each time I click, we see some logs related to what app is doing. And we see as well here OneAgent SDK process. It should show in a minute, because I wasn't clicking before. I think I need to do some more clicks. Sometimes it takes about a minute to show up, because if OneAgent SDK is not used, it's suspending and not showing up in the Dynatrace GUI. But after a moment, it's showing up normally. Okay, maybe I will make things a little bit faster. Here's. Okay, I know what I've done. I've messed around with one thing. I restart the server, but I don't think I provided the license to it. But doesn't matter. We have data from yesterday, I think. So as you can see here, we have auto-detected custom services, messaging services, queue listeners, web requests, and of course, database statements. And if we go to traces, we can go to service flow. And we'll see transactions that are going through our application. And this is done totally automatically. You don't need to touch your application to make it happen. And this is really what you can achieve using OneAgent SDK for C, for example, or OpenTelemetry, and create own agents, own instrumentators. When you think about this as a process and what you want to achieve without breaking the application. Yes.
Could you do me a favor, and can you open up one of these distributed traces? Maybe the one that you start on the top. Yeah, exactly. Click on the trace.
No problem.
That would be awesome.
I will filter some things and go to the traces.
Yeah, that's great. And maybe, so that's basically also coming back to the demo you had earlier with OpenTelemetry. So we would visualize an OpenTelemetry distributed trace with all the spans and attributes in the same way. And this is now here instrumenting your Ruby on Rails app with the OneAgent SDK. But as you correctly said, whether you're instrumenting it with the OneAgent SDK, which is Dynatrace proprietary, or whether you do it with OpenTelemetry, Dynatrace would then give you all the insights into distributed traces like here.
In general, Dynatrace sometimes treating the OpenTelemetry traces the same way that PurePaths. When we go to distributed traces, we can switch from PurePaths to ingest traces, and we should see the traces there if there are any. But the level of data in general should be the same if you are doing things right. So right now we are working on the approach of this agent that will be working on OpenTelemetry, because we want to mitigate some edge cases that are limiting us with OneAgent SDK, like Alpine Linux images that are sometimes happening on customer environments, or what I've said related to the developer machines, that they cannot use the tracing because obviously OneAgent SDK for C is built for Linux and Windows and x67, x86, not for ARM Macs that are popular right now. And
yeah, one thing that I want to highlight here as well, because in the very beginning of your presentation, you talked about you need to plan your instrumentation. And here we see it really nicely. We see the entry point. The entry point is basically where the request comes in on port 3000. We see we call the external calls. They give an call to an API, nasa.gov. You have calls to queues. You have calls to a database. And you have also instrumented important frameworks and important methods like rendering, certain layouts here, it seems. And I know you've done this great automatically with your support for Ruby on Rails, but I think this view alone just really shows exactly what you highlighted. You need to figure out where do you want your distributed trace to start, and what are the important pieces along the distributed traces.
Yes, and even if you don't have information in between of some parts, because sometimes you have this waterfall with some gaps that you cannot understand. You know exactly between which points this gap is happening. So in such case, you can do some extra instrumentation, add something there, and you will see it. For our Ruby agents, we are supporting auto instrumentation on similar way that Dynatrace is supporting this. So obviously we cannot do this from the Dynatrace GUI, but we have environment variables that can be passed, and these environment variables then have address of particular model, class, and action inside of it. And then after the application restart, this be instrumented, and you can cover this. But this is something you are doing on the data you already have. You don't think about, okay, this point, one more point there, one more point there. You think you're only covering this you need. And as long as you need, because if you will resolve the issue, you may not need this part of the application instrumented. And this is something we are doing for our customers with the regular Dynatrace, because we are doing some custom instrumentation when we need. And if the problem is resolved, the code is rewritten, and the problem is not happening anymore, and there is no chance that will be happening because of changes we've done, we are disabling this instrumentation because it's not needed anymore. If you have shorter spans, you have better data retention as well, because you don't need to store all those informations, unnecessary informations that you may not need. Sorry.
It's okay.
And it's easier to see, because you can see more of this trace on single screen without scrolling, and it's easier to understand the transaction in general. And obviously, still you have technology of tagged follow that is used by Dynatrace. So all the headers that are going through Ruby are processed the same way that for regular agents. So if Ruby is part of the transaction, and there are, for example, Java before and Java after, you will see the whole traces that are going through this technology. And this is something that is already working. But what is interesting, and maybe interesting for you, is that we have as well this stuff related to Delphi. So we have simple project that is provided by us to the customer that can be fired, and this project is firing such application where you have the same examples you have in documentation for OneAgent SDK for C. So the same examples you have there are translated to the Delphi code, and you can execute them directly from the simple form application to make it easier to understand and easier to read. And as you can see here, as you click through this part of the application, you see the PurePath ID here, the Dynatrace header then. And you can click through those informations, and then all of them will show in Dynatrace, and I can show you that as well. Should be this host and this host.
It's really great that you are, typically when we talk with people, We often talk about web applications. We often talk about the classic like serverless. We talk about technologies that everybody talks about, but you are now showing us stuff that I, don't see that often, like Delphi, right? I guess I haven't seen that in a while. But
I thought this technology is not used widely, but I was wrong in general, because Embarcadero is still developing this. And you have frameworks to build mobile applications based on this, web applications and other stuff. And there is a really huge community that is still using it. So it's really nice to have chance to make it work. So as you can see here, this is the result of my clicking on this GUI. And we see some request attributes is collected, and we see the same level of data I've showed you on the Ruby stuff. So you have some entry points, some custom methods, DB statements, exit points, and other things. So all that that is available on OneAgent SDK for C is as well available for Delphi. And we are as well providing services to our customers to help implement such things. So to make things easier, because as I mentioned before, this is something that has to be properly planned and needs some context to make things fast enough and well enough to have proper data, good efficiency, and do not waste too much resources to build the solution itself.
Yeah.
And I think in general, this is all I had for today.
Yeah, that's awesome. Hey, Sebastian, thank you so much for doing this. I think, to recap, great introduction about how important it is to do manual instrumentation properly in case you have to do manual instrumentation. All the thinking process behind it. You have done this for many, many years with your customers. You've done this initially with the OneAgent SDK, but now you're moving over to OpenTelemetry. And I think you gave a nice overview of when you would choose the other one. I guess in the future, we will see more OpenTelemetry because it's the de facto standard out there. A lot of observability platforms are supporting it. The tooling support will get better and so on. But no matter what you use for instrumentation, the basic principles are always the same. Do the proper planning, don't over-instrument, figure out what you want to collect, put it as close as possible into your code, because otherwise you have to maintain too many things and it's becoming really hard. And I also take you up on the offer to do another session, especially around C++ implementation with OpenTelemetry, either here as a community episode or maybe with Henrik from Is It Observable. We'll figure this out.
Yeah, this is a good idea.
Cool. And all the links that you've shown today, please, after the recording, send it over to me, then I will put everything together into the description. All right. With this, I want to stop the recording. Thank you so much. See you next time.
Hey, bye.